Hi, and welcome to my presentation. My name is Arthur Carvalho. I am an associate professor at Farmer School of Business, Miami University. My talk today is about the well-known domain of food delivery services. Recent advancements in ICT, information communications and technology, have enabled customers to easily connect with and remotely place orders at local restaurants. If you think about restaurants, on the other hand, they may have in-house or outsourced delivery workers on call, ready to deliver orders. And in between all these stakeholders, customers, restaurants, and delivery workers, we usually have platforms like Uber Eats, DoorDash, Grubhub in the US, or iFood in Brazil. Our work will be primarily centered on these platforms and how to potentially replace them. If you think about the business process of these platforms, that process is highly profitable. Why? Because there are two fees that these platforms charge. On the one hand, they charge delivery fees. These are fees charged to customers for the delivery services. At the same time, the platforms also charge commission fees. These are fees charged to restaurants on a per order basis, and that can range from 10 to 30% of an order. So put these two together, once again, these platforms are incredibly profitable. The flip side of the coin is that all these fees place a tremendous burden on both customers and restaurants, and many of which now, because of COVID-19, they face a decline in disposable income and sales. At the same time, these platforms also have access and single-handed control over precious data that are the byproducts of the purchases placed by customers. So whenever you go online on one of these platforms and place an order, that data about your food preferences will be stored by the platform owner. And based on that data, these platforms can also derive information about the sales volume and prices charged by different restaurants. So with that said, what we suggest in this paper is a new solution, which is blockchain-based, to help customers place orders straight with restaurants. No need for intermediaries, no need for decentralized platforms. At the same time, we use smart contracts to help the coordination with delivery workers, to make sure that everything is well synchronized within that ecosystem. In terms of methodology, we apply a strong design science approach. So let me go now to the first stage of that approach, which is to discuss the problem motivation. So to better understand the problem of food delivery, we interviewed the main stakeholders, key stakeholders in 2021. All the interviews happened in Recife, Brazil. We interviewed a total of 8 restaurant owners and 34 customers to understand the problems they faced before and that they continuously face today. Our key findings are, number one, all restaurants, no exception, they rely on a third-party food delivery service. They use a platform well known in Brazil called iFood. Moreover, 62.5% of the restaurants consider the food delivery platforms to be the main channel to sell the products to customers. As we mentioned before, all the commission fees range from 10% to 30% of the cost of each purchase. And an interesting finding was that all the restaurants, no exception, all of them reported raising the prices of their products on food delivery platforms from 10 to 50% to pass on the costs to their customers. The flip side of the coin, when we talk to customers, 58% of them said that passing the costs is unfair, it's an unfair practice. Putting all that together, what the discussion tells us is that the costs should be at the forefront of any solution to food delivery. And that leads us to design our first requirement. Our first requirement says that food delivery services must be supported by economically feasible systems. Now, continuing with that interview, we asked the stakeholders about potential issues that happened before, and they mentioned a range of different problems that happened in the past, like wrong and missing items, late deliveries, missing wrong addresses, and so on. The restaurant owners, they told us that problems occur in 1 to 5% of the orders, and they mentioned something really interesting, that the delivery worker is responsible for 75% of the problems. The restaurant said they usually take responsibility for the costs to avoid potentially bad online reviews, and the food delivery platforms pretty much always side with the customers. Now, the customers also mentioned they faced problems. 95% of them faced problems before. And perhaps what's interesting for our purposes here is that they believe that not the delivery worker, but the restaurants are responsible for most of the problems. So what the above discussion highlights is the need for unambiguous and transparent transactions and dispute resolution rules. That said, our second design requirement says that food delivery services must be supported by systems that have transparent and standardized transaction and dispute resolution rules. Now, going to the next step, we thought about privacy as well. Of course, it is essential to consider stakeholders' privacy when developing food delivery solutions. For example, customers might not want data about their food preferences, order time, or address to be available to the public. That led us to define a third design requirement that says that stakeholders, primarily customers, identifiable data should not be available to the public. Now we move to the next step in our methodology, which is to define high-level objectives for a solution. And every single one of the design requirements we mentioned before will naturally flow into one design principle. So think about the first design requirement, which relates to cost. The associated design principle says that stakeholders should perhaps transact in a peer-to-peer fashion, because if they do so, we can remove this centralized entity, which is the platform, and make transactions cheaper. The design requirement number 2, which relates to transparency, has the associated design principle that says that transaction and dispute resolution rules should be coded as immutable and transparent algorithms. So it's open to all, everybody can see how these resolution rules actually work. And third, when it comes to privacy, our third design principle says that cryptographic primitives can be used to make sure that only authorized people can have access to private data. So given all these design principles, the next step was to create a solution, what we call an artifact. We developed a blockchain-based artifact that relies on on-chain and off-chain data storage. We will focus primarily on on-chain storage, but just to let you know what is off-chain, we think about data about products. This data will be stored by restaurants either using their proprietary infrastructure or public domains like Google Maps. And in that specific storage, they can add constraints when it comes to maximum delivery distance, for example. But our focus henceforth will be on on-chain storage, where we keep data about transactions involving stakeholders, as we defined before, restaurants, customers, and delivery workers. What we have now with blockchain is an immutable log of time-stamped transaction, and we can use that in our dispute resolution mechanism. So that said, I want to briefly explain how our artifact and underlying business process works, and I want to emphasize that a much more detailed version of it is in our paper, and we use in our paper BPM, the business process model and notation. Here we have the main stakeholders, customer, we have the delivery worker and the restaurant. In between them is no longer a centralized platform. We have a blockchain-based solution plus smart contracts. In step number 1 in that process, the customer will place order with a restaurant, and the customer will issue a payment that covers the order plus delivery fee. That payment is in escrow, is held in escrow by the smart contract. Now the restaurant is notified. The restaurant can accept or reject the order. Let's say the restaurant accepts the order. Now we have a pool of delivery workers who will be notified. One of them eventually will accept the delivery. Note that when the restaurant accepts the order, the restaurant puts some money in escrow as well, and that's a delivery fee. And the delivery worker also makes a deposit, puts some money in escrow. We will explain why that is required in our dispute resolution mechanism. I just want to emphasize that the deposit by the delivery worker can be any value whatsoever. We are agnostic when it comes to the specific value. Now we go to the next step, step number 4. The customer will now have to report private information to the delivery worker. What the customer does is to take the delivery worker public key, encrypt private information, and put that encrypted information on the blockchain. Now the delivery worker can retrieve that information, and only the delivery worker can decrypt the information. Next, the delivery worker will collect and verify the order to make sure that all the items are accurate, and the delivery worker and the restaurant will update the status of the order using the smart contract. So now we have a time-stamped update of the order that determines whether the delivery worker agrees with the restaurant and everything is fine or not. Now going to the next step, step number 8, the delivery worker will deliver the order and the customer and the delivery worker can update status. They pretty much can say whether everything was fine or not. Now I want to explain our dispute resolution mechanism next and how that money in escrow is actually used when we try to solve disputes. I'm going to focus on only 2 cases, but we have a few other cases in our paper, and all these cases, once again, they are codified inside algorithms and they're handled automatically. So let's say we have the first case. The first case, the delivery worker notices that the order is wrong before delivery. Maybe some items are missing. So now the restaurant can do 3 things: disagree and call a new worker. When that happens, the previous worker receives a deposit back. Number 2, the restaurant can agree and fix the order. So we just pause the process for a while, then eventually it continues. And number 3, the restaurant can agree and perhaps just cancel the whole order. Let's assume the third case happens. Then when that happens, the customer receives their money back, which is the number 1, the money in escrow. The delivery worker receives some compensation, which is the delivery fee, which was in escrow before, plus the deposit back. The whole thing again is automated. Let's have another case. Let's assume that the food is delivered and the customer complains. Now, if the customer complains, it will be the words of the customer against the words of the delivery worker, assuming that the delivery worker does not accept the complaint. So now the restaurant has to break the tie. If the restaurant does not accept the complaint, the delivery is deemed successful. On the other hand, if the restaurant does accept the complaint because, say, the delivery worker was late, and there's a way to actually check that based on time-stamped transactions on the blockchain, when that happens, the customer receives their money back, which is number 1. The restaurant receives the deposit made by the delivery worker as the compensation, plus the delivery fee that it did deposit before, right? So you can see how our mechanism here works as some sort of a proof of guilt consensus mechanism. We need at least 2 stakeholders to implicitly agree with an outcome of a dispute so that we can process and penalize whoever the guilty person is. The blockchain stores a time-stamped chain of acknowledgements and deposits in escrow. And with that, we can cover expenses and eventual sanctions. And the whole thing, again, is automated. I just want to emphasize that we evaluated the artifacts in our paper with respect to cost, transparency, and privacy, and we also developed a fully functional prototype. In the interest of time, I'm going to skip these 3 steps now and go to the conclusion. To conclude, we proposed a blockchain-based solution to replace food delivery platforms. Through chains of acknowledgements and escrows and clever escrows, our solution is able to implement an automated dispute resolution mechanism. As future work, we want to extend our work and improve it even further, have more design iterations. We want to have ex-post interviews with stakeholders, ask them about our solution. That will perhaps create new requirements and new principles. Eventually, what we want to do is to create a design theory for generic delivery services, not only food, but any delivery service whatsoever. And that is it for my presentation. Thank you so much for listening. If you have any questions, feel absolutely free to email me.